Now, the other thing we learned in chapter 1 is how to do density. Remember, density is this simple equation. Density is mass divided by volume. I shouldn't really put a capital D, maybe a lowercase d. Sometimes it'll be given as a rho, Greek letter rho, but because density is not actually a path independent function. But I sometimes abbreviate it as a big D just because it helps us remind what we're looking at. But density, it's mass over volume. There's 3 different types of problems we could see if we're dealing with density. We can always solve for mass given a volume and a density. We could solve for volume given a mass and a density. And we can just solve for density given the mass and the volume. It all depends. The key thing to remember is just to watch the units. Watch the units. Because density is given as a mass over volume. So if you have milliliters as your volume, you're going to get grams per milliliter. If you have liters, you're going to get grams per liters. This is kind of important when we're dealing with liquids versus gases. The density is grossly different. But density is one of the easiest things to solve for given its idle simplicity. But if I said an object with 15.35 grams of mass, it has volume of 18.92 milliliters, what would the density be? So just setting that up, we identify, okay, we're given mass in grams, we identify a volume in milliliters, so we're going to use the equation as given. Solving here, make sure we have this all set up. Note that as we do this division, there's 4 sig figs here, there's 4 sig figs here. Regardless of what my number is, I should technically report it to 4 sig figs. Now, because the units, grams and milliliters, are different, they cannot cancel, so they will be carried over in our final answer. 18.92. So our answer should be 0.8113 grams per milliliters. Had I recorded that less accurately, I would have to round this down. As it is, it's a whole mess on the calculator. I'm getting 81131078.2, but I have to kill it at the 4th place, and 1 rounds down. Now, if I was given, like, say, like 85 mils of liquid with density 0.812 grams per milliliter, what mass would it have? So in this case, we're going to rearrange our equation. Always, 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 we have to know how to rearrange our equation, because this is the bread and butter of chemistry. We have one big equation. If you can rearrange it to solve for the unknown, you don't have to memorize 3 different versions of the same thing. We could just move things around. Remember, we're multiplying to get mass by itself. We have to multiply both sides by volume. volume over volume cancels out, and so our equation is rearranged to mass equals density times volume. Our volume is 85 mils. Our density is 0.812 grams per mil. Mils on top cancels with mils on bottom, leaving us units of grams. 0.812 times 85. Now we have 2 sig figs here and 3 sig figs here. My numbers should be reported as 2 significant figures. Even though my calculator says this should be 69.02, I can only report this as 69 grams. 69 grams. But that is essentially density. This whole conversion thing of rearrangement of the equation will keep coming back to us. It will keep coming back to us as we continue to look through this material.